Arizona State University. So, Nick, the floor is yours.
Thank you. Testing. Thank you, Nasser. It's a privilege to be here today. I apologize, I'm still working on my Arabic, and I hope you can understand me. It's my first time to Saudi Arabia, and I've been very pleasantly surprised by all the great hospitality and the warm welcome, so thank you very much. First of all, I just want to state that the comments that I will make are my own and not necessarily those views of the company I work for. So I want to start by introducing Samsung. I'm glad to hear that the prizes were selected to be such excellent products. I hope the winners will enjoy them very much. And a little bit about the group that I work for. We are Samsung Semiconductor business, and Samsung Group is a large multinational company headquartered in Korea, and they include Samsung Electronics, Samsung Heavy Industries, and many other businesses. Within Samsung Semiconductors, our group makes memory chips, displays, and various other foundry products. The group that I'm part of is System LSI, which makes system-on-chip products, primarily for mobile devices, various computing devices. The group I work for is responsible for GPS and location technology that will be used in future handsets, including the Galaxy line. So a little bit about the smartphone market globally. And this is public information, so I'm not disclosing any important secrets here. In 2013, according to Gartner, nearly 1 billion smartphones were shipped in the world. Of all of the mobile subscribers throughout the world today, approximately 58% have smartphones instead of feature phones. The prediction this coming year in 2014 is that the installed base of smartphones will exceed the installed base of PCs. That means that more smartphones will be in use than PCs, desktop and laptop PCs. And that's a startling realization that the devices that we're carrying around in our pockets are all of a sudden the largest computing platform in the world by volume. So what does this mean? The implications of this, well, first of all, since smartphones almost universally include GPS or GNSS receivers, it means that smartphones are the world's largest application of GNSS. With the growth of smartphones, it's now the highest volume computing platform, and because they have GPS, this platform, it means that all these devices are location-aware devices. Lastly, the use of location-related services is now mainstream. When I started my career at the University of Calgary studying GPS, things were a lot different back then. And we had visions of GPS being a mass market product, and now it truly is. A little bit about some of the experiences that LBS provides today. Location-based services that you probably don't even realize are enabled by location. Mapping, of course, and navigation, of course, are enabled by location, but also search. Every time you do a search using Google, it improves the results based on knowing your location, and it will provide you location-relevant results. Also, every time you check in using Facebook or other social networks, your location is used, and your friends can see where you are, and you can show locations of where you are. these are such common use cases that everyone has gotten very familiar with them and used to them, and it's a daily experience. People also use LBS for fitness, for tracking each other, for locating their children and loved ones. And the ecosystem that enables LBS is vibrant and rich with content, with crowdsourced material to keep everything relevant and up to date. It's a very rich ecosystem. Samsung is a market leader in smartphones and tablets, and we have mass market devices shipping in every region of the world. It's clear that for our products, LBS improves the quality of the product and the quality of the experience. And consumers now have come to expect location to work everywhere, not just outdoors where GPS works, but everywhere, including indoors in facilities like this, and in shopping centers and in airports and other locations. In fact, consumers are indoors more often than they are outdoors, and so indoor positioning is critical to improving the LBS experience overall. Looking beyond the smartphone, you may have heard the notion Internet of Things and various devices becoming internet connected with Wi-Fi and Bluetooth and other communications technologies. Not all of these devices will have GPS receiver in them, but they will all become location aware as they are connected to other location aware devices within their network. So a little bit about some of the requirements for a rich, vibrant LBS ecosystem. First of all, in order for LBS to work better indoors, we need better positioning indoors, and we need better technology for positioning, better cooperation from carriers, and better standards to proliferate indoor technologies. Right now, indoor positioning is nascent, and if you use your phone today and go on to maps, you might get a position inside, you might get a position that's over on the street. Wi-Fi is sometimes used for positioning indoors, but it's not that great yet, and we need to develop, as an industry, we need to develop better techniques for positioning using Wi-Fi and other technologies indoors. For example, Bluetooth low energy beacons, BLE, can be used for positioning based on proximity, and they can also be used by ranging in order to determine your position more accurately indoors. There are other technologies, including NextNav's MBS, a metropolitan beacon system that's being developed in the US for indoor positioning. There's also MEMS sensors, these devices inside cell phones that measure attitude and angular rotation and compass heading, acceleration. These sensors can be used for determining your positioning while you're walking indoors. And also there are some techniques using magnetic fingerprinting or RF fingerprinting, very survey intensive techniques, but they can be used for improving position indoors. The next biggest part of the requirement for LBS experiences is a strong GIS component. Everybody is probably familiar with products like Google Maps and Apple Maps and other map products on cell phones. And predominantly those cover streets and the road networks, but it's only been in the last 2 or 3 years that we've started to see maps for indoor venues start to appear. For example, this image is a map of a mall in the United States, and you can see that indoors it's got all the store names marked out, and over here on the right it's even got levels indicating the different floor levels of the building. And so if you click on those, you can see the stores in the different levels. This is a much more detailed map than has ever been available in mapping products. These indoor maps need to have not only the geometry, but also the connectors like escalators and stairs, This is a very big challenge for the GIS industry to gather all this information and capture it in these indoor maps. We also need businesses, services, including restrooms and other points of interest inside the malls and airports. We need retail information like the websites and the contact information so that you can find the stores or services that you're looking for or the gate that you're traveling from. We also need real-time content, special events, promotions, hours of operation, sponsorships, things that will help you to have a richer experience while you're shopping or traveling. The data inside malls and other indoor locations changes much more rapidly than the data outdoors. The stores and the hours, the other attributes change quickly, and so this is an important challenge for the GIS industry in capturing information about indoor locations. A little bit more about indoor positioning requirements. An indoor positioning system is any system that can be used to determine the position while indoors. And GNSS works in some places, especially if there's a mall with a glass ceiling. But when it does work, it's not always very accurate. So we definitely need something to improve the position indoors. You can see this in this example. This mall was a single-story mall, and I actually was able to get a GPS position indoors, but it wasn't very accurate. And using Wi-Fi positioning, there was a much more accurate position available, and it shows exactly what store I'm next to inside the mall. And because this map here is enabled with an indoor map, you can see what level you're on, you can see the nearby shops, and you can see all the content and services that are there. A couple of examples to give you an idea of the capability of indoor positioning today. This is a test that's done with Wi-Fi positioning system, and the green arrows and the red arrows mark the path that was walked inside these two malls in California. And the Wi-Fi position you can see is a little bit jumpy. It bounces around a little bit. This particular positioning system was based on signal strength to Wi-Fi access points. And because the environment is dynamic with lots of people causing interference, the Wi-Fi signals have a lot of variation, and so you get a little bit of jumpiness. But the position performance is better than GNSS, and you can actually get an idea of where you are inside that mall. The big advantage of Wi-Fi positioning is that virtually every building in the world has Wi-Fi infrastructure in it today. So if we can use that infrastructure to determine a position, it will mean that we don't have to invest additional money in infrastructure. Here's an example of a pedestrian dead reckoning where the sensors that are already in a cell phone are used for keeping track of your positioning as you walk along. And compared to what was possible even just a few years ago, this is very good results from very low-cost sensors. However, there is still a drift, and so any positioning system that uses MEMS technology needs some way to periodically determine the absolute position to improve this. And of course, Wi-Fi is one candidate technology to do that. Here's another example of, in this case, this is a mall in Korea, the COEX Mall, a very large mall, multiple levels. And you can see that the indoor map is very detailed. It has all of the different attributes that we've discussed. And this is a test. The green line is the path that was walked, and the red is the result computed using Wi-Fi positioning. You can see it's a little jumpy, but it is able to figure out where you are. And ultimately, I believe the best solution is when you combine these results together and you get the smoothness of the MEMS and the absolute positioning accuracy of Wi-Fi. These maps, importantly, are searchable for the content that the consumer is interested in. So we see that detailed indoor maps are a key enabler for extending LBS experiences to the indoor realm. The geometry is important, the business listings is important, and most especially the dynamic content and being able to keep that up to date is very, very important. We also see that smartphones are a key source for creating this indoor content. The smartphone that you have in your pocket is constantly in communication with various servers, and that the information that is on your phone can be used for improving maps, for creating maps, for improving maps, for monitoring content, and this can all be done in legal and anonymous ways and for the benefit of everybody in the industry. Sometimes the users get proactively involved in improving the content by providing reviews and feedback when there's erroneous information. The GIS systems that we employ need to be able to capture this information and dynamically publish it to the maps and applications that are used by consumers. So just a glimpse of the vision. This is a fun little graphic that you can see satellites providing satellite-based positioning, and indoor in these different use cases you can see these little beacons providing supplementary location information indoors, and a whole bunch of different use cases of people tracking objects and tracking other individuals, being notified of inventory problems in a factory line, being notified of people's movements inside secure areas, people people using the data to manage their businesses more effectively. All of these mobile computing devices can be used for monitoring and tracking these objects and individuals. All of these solutions are enabled by GIS and real-time communications. Some conclusions that we draw. First of all, the mobile market is a very significant computing platform in the world today, and it's continuing to grow. The location, latitude, longitude, altitude, address, floor level, these are pervasive data elements in the realm of the cloud and GIS networks today. And this location is critical for the creation and use of content for consumers. GIS investments and research should include a strong indoor component so that we can better manage these elements that are important for LBS. And lastly, I think good news for all of us is that it will be harder and harder to get lost in the future world we're approaching. Thank you very much.
Thank you very much, Blake. And I know that in the program we have about 40 minutes at the end for questions, but maybe I can take for 5 minutes after each speaker, just in case, because we might run out of time. So we have 5 minutes for questions if there's any for